Okay, everyone. In this video, we are going to discuss about the projectile motion. And there are many cases we are going to consider, but the most important part we need to remember. Any object thrown in space with different possibilities, but only affecting force on the object is the gravity. So if we are on the ground, no matter if we are on a building, whatever we have, when we are throwing something upward could be, if we are dropping something could be, projecting something, no matter what we are doing, only affecting force is the gravitational force under the influence of gravitational acceleration that is equal to 9.81 meters per square second. Nothing different for this situation. G equals 9.81 meters per square second. Okay, so we are going to consider a few cases over the next couple of days. Things could be simple as on the ground, you have a ball. You are going to project it straight up. Could be V equals 10 meters per second, any number. This object will go straight up and it will reach the maximum height. It will descend downward along the same line, same path. Or if I need to draw it better, I could say this guy is going up, then going up, maximum height, turn around, it is coming back. But the idea is it's going to go up in the same direction, same path and coming down. Also, one of the most common projectile motions you will see is there's a ball, could be any kind of a ball, any object. You give a velocity V, could be 30 meters per second, with an angle 30, 40, 50 degrees, with an angle to the horizontal. This will do a parabolic motion and it will reach the ground level after some time. So it will reach the maximum height right here, and from the start until this point it is going upward, now momentarily at rest, not going anywhere up, but then starts descending downward. Also, there are a few other cases we can think about. If you are on top of a building, from this edge, we could think of, again, the same situation. With an angle, you are projecting something. In this case, you are on top of a building on a cliff. It will do the same scenario, let's say angle theta or alpha, whatever. It will do the same case, the projectile motion. The only difference now, until it reaches the ground level, it is not reaching the same level, the level it was projected, but it will further go down, will go to the maximum height, start descending further until it reaches the ground level. So these are few cases. And also, we could think of from a top of a building or a cliff, we could have a situation, here we go, here is the ball. Now you are going to project it downward with an angle theta, let's say velocity V initial. This could be a situation. It is going to reach the ground level. So it will do the same case, but now a parabolic shape only downward until it reaches the ground. Also, there could be situations you are going to just drop something. Drop, this is the case, drop. V initial downward equals 0. You are dropping it. And it is going to go down, reach the ground level. Or could be throw. From the same level right here, instead of dropping, you are going to throw it downward with initial velocity 10 20 meters per second. It will go faster because of this initial velocity. Now, the most popular case is this guy, throwing upward from the ground level with an angle theta. The later part of this video will talk about how to take the velocity components, the vector components towards the x direction, towards the y direction. If I call this is my x hat, if I call this is my y hat, taking the velocity components, okay? Now, everyone, in this simulation part, we have a case. We had the football game yesterday. So we have this player ready to kick this football. This is going to go in this parabolic shape, the projectile motion. So now, whenever we see this situation again, here I have my horizontal forward along the horizontal direction. This is my x direction. Vertically up, this is my y direction. Now, whenever this player gives this velocity v with an angle theta to the horizontal direction, angle theta could be 30 degrees, velocity 20 meters per second. Remember, we need to be careful about what is the initial velocity v component along the x direction. Velocity v, the angle theta to the angle direction. Here we have the v times cosine theta along the x direction, velocity x component initial, and initial velocity y component, velocity away from the angle should be a sine v sine theta. And this object will start moving. Here we go, it's going to do the projectile motion. Now, we need to be still careful. It has a x component of the velocity at each point of this motion, y component of the velocity. The object is now going up, up, up until it reaches the maximum height. Then it starts descending downward. X velocity component always be along the x direction, no matter going up or going down. But keep watching this simulation. The y component, when it is going up, it will be upward. But after the maximum point, when it is descending down, the direction of the y velocity is changing. So we have it is upward, y velocity is still, x is horizontal, and right here, after the maximum height, y direction velocity component changes the direction and it reaches the ground level. In class, we will talk about more examples how to do these problems.